So welcome to the section number 13 of the course Express System with C++ and Qt. And now we are going to talk about a derivative class from the syntax analyzer that is called RPM syntax analyzer. Therefore, we are going to develop a function called compile that will analyze a set of rules for validation of the syntax of the rules course. So first of all, let's discuss what is RPM, why we are going to use it. So by reference, RPM is the abbreviation of reverse Polish notation. That is a notation where every operator follows all of its operands. This also means that we don't need any parentheses as long as the operator has a fixed number of operands. To make an example, let's put infix expression. Infix expression is the one that we are using in math usually. So for example, 5 times 4 plus 3 minus 6. Okay, so as a basic math, we're going to start with this expression. 5 times 4 is 20, plus 3, 23, minus 6 is 17. Okay, so how is going to be in the RPM notation? How is the expression is going to be made? How we can see it in our computer? So with the same expression there it's above of this row. This is the RPM notation. I'm going to explain it. 6 minus 1. Okay. First of all, you need to notice that the infix expression we need parentheses to determine the priority and order in the sequence of operations, but in the RPM we don't need any of them, so that's cool. And so look at this expression, we don't need any parentheses. So I will tell you that the RPM it's evaluated from the left to the right, and we're going to use a stack to save the latest operation to use it in the next one. Let me explain it in better ways. So for example, remember from left to the right. So the first element that we are going to determine to process is the 5, and we're going to put it in the stack. Okay, so it's in the stack. Alright, so we don't care about this 5 until we reach operation. For example, the next one is 4. Save it in the stack. The next element is the multiplication operation. That it goes to the stack. Okay. So what's happening when we reach one of the operations? Pretty simple. We're going to take it. I don't know, we have a variable, and this variable is taking the top of the stack. So the top of the stack is the multiplication. I take it, and it also takes the 4 and 5 operands and process the operation. That it's 5 plus 4, right? And what are we going to do is to save temporal variable that its value is 5 times 4, that's equal to 20. We are going to save it in the stack and save it to the stack. Okay, So let me show you the state of the stack. This is pretty simple. This is the button. As you remember, the stack is first in, last out. It means that this is the top. Imagine a container. You know, this is stack. It's pretty basic. And so we take the multiplication operand from the top, and we process it. Then the 4 and then the 5. Okay. So the stack state now is just temp1, which value is 20. So next time we just process this part. The next one of element that we are going to process is the 3 to the stack. Okay, we still have it in the stack, and then we got the plus, the addition operator. It was found, and we save it to the stack. You can even don't save it in the stack. It means about optimization. If you don't need to save it in the stack, it's about your implementation. So don't worry about it. But this is just an example. You can save it or not. So we're going to do the same, but now we're going to plus takes away our processes. Check it, and also the 3 and temp1. Its value is 20, and process the operation. Okay, so it's temp1 plus 3. So we're going to create a new value, a new variable that it's temp2. That's equal to 20 plus 3, and its value is 23, of course, and save it to the stack. Okay. So the next stack state is just temp2. This is a pretty simple example, so it's just this stack can be very evolved in a huge stack. So just an example. You may see that when we are going to, in our implementation, this stack will be a beast. So well, let's continue with this. So then we processes all this part, and then all these elements. So the left the elements that are left is 6 and minus. So we're going to put the 6 to the stack, and also the minus to the stack. So again the same, take it, and also the 6 and temp2, its value is 23, and process the operation. Subtraction, that is temp2 minus 6 and temp3 equal 23 minus 6 equals 17, and save it to the stack. Okay, so this is the last element, and this is the end of these processes. So we can determine if the syntax is correct at the end. We can also determine if the syntax is incorrect between the operations. So as you can see, this procedure is craving for being developed. I mean, it's pretty simple. It seems that it's a process that can be reached very easily. So with this explanation, we're going to continue with the development as well. I mean, rather of the development, it's the definition, because the development is quite complex. So we're going to take it to the next video. So as usual, understanding this, you see that it's pretty simple. For instance, this we're going to create a new class as always, as usual. With new, and to create a C++ class. The name is RPN Syntax Analyzer with Y. No. Publicly inheritance from prop syntax analyzer. There's nothing. The cute is not related, and it's cool. So, oh, I almost forget the P. Props analyzer, syntax analyzer. Just missing letters. Next, and here we are. So next in the header, we can create a constructor with the same parameters to the abstract. Wow. And hold on. To the how do I say? About the constructor with the same parameters of the abstract syntax analyzer. So let me just remember how to do that. Okay, this is the constructor. All right. So therefore, we need to build the base of the base class, and it's not parent; it's just base class. So RPN prop need to define include include prop. Oh, sorry. Okay, prop syntax analyzer, write it, detect this, prop next analyzer. It should be in the definition of prop text analyzer, so it detects text automatically. Prop tree builder. So let's do it in line with initializer leaks. And what we're going to do is to prop syntax analyzer. I'm going to build it with the parameters that we already have here. We're just passing the parameters. We don't have any to build different from the base class. So that's it. Pretty simple, huh? Let me just build it just to make sure that it's working this, because sometimes I forget to do it well. So, oops, CPU was not declared in this filial. Lol. Come on, dude. I know what's going on in this part. Arrivederci. Yeah. I hate when there are errors that I don't understand the first instance, but it's okay. So next step, as you might remember, we're inheriting from an abstract class. You know, this is abstract class virtual, pure virtual. It means that we are having a abstract class, and so we need to override the compile function as well as declare the destructor virtual. But I remember that in the abstract class don't have to have the compile as public, so we can put it as private. This is because there is no situation that we will need uh, to derive the class, use this function in the derivative classes, or instance the perplex analyzer and call this function. So let's put it private. We'll have it to make it C++ effective. So as I remember, we can do this virtual compile. Some people say that we need to have the virtual destructor also, doing something like this. RPN analyzer. But it's not necessary, because when we are having the keyword virtually means that we're saying to the compiler that we are going to derive this class, but this is not the case, so I think that this is correct. I hope so. Oops, sorry. Let's see. Virtual. Sorry. One. Okay, everything is fine. So it compiles. This is the end of this video. The main purpose of this video was to explain the RPN and seeing that it's pretty simple. I hope you enjoyed it. Leave a comment if you like it and if you like this video, and share with your friends if you want to. The next video we're going to implement the compile function. So thank you.